Lesson 116, division by zero, and the appendix lesson, quadratic formula. Here we see division by zero, where if you write it as a fraction, n divided by zero, like a variable number divided by zero. You'll notice that it says no, so you can't divide by zero. If you have zero divided by anything else, you can see that it says okay, 0 divided by any number. So 0 divided by 0 is undefined, and there's no possible way to get an answer. So today we're going to explore why that is the case. So our first example says, find each set of quotients, and as the divisors become closer to 0, do the quotients become closer to 0 or farther from 0? So we take a look at letter A. 10 divided by 1 is 1. 10 divided by 0.1. Remember, when we're dividing with decimals, we can't divide with decimals, so we need to move the decimal place to remove the decimal. That means you have to do that in the numerator as well. So now it's really 100 divided by 1. 100 divided by 1 is 100. And this next one, move the decimal place 2 places to make that 1. Move it 2 places into the numerator. That would be 1,000 divided by 1, which is 1,000. So for this one, as we were getting closer and closer to dividing a number, like the divisor is closer to 0, our quotient was actually getting further and further from 0. What about the second one here, dealing with negative? So 10 divided by negative 1 is a negative 10. 10 divided by negative 0.1, move the decimal place 1 point. So now we have 100 divided by a negative 1. That gives us a negative 100. 10 divided by negative 0.01, move it 1 to the left. Move it, or 2 to the left, move it 2 to the left in the numerator. We have 1,000 divided by negative 1. That gives us a negative 1,000. So what happens to these numbers as you get your divisor closer and closer to 0? From the negative side, when you're getting closer and closer to 0, your quotient is actually getting further and further away from 0 to the left. So to sum everything up, the closer your divisor gets to 0, the further and further away from 0 the quotient gets. So if you have it on the negative side, the closer you get to the 0, it gets further, the quotient goes further and further to the left. When you are on the positive side, when you're getting closer and closer to 0, the quotient goes further and further to the right. Second example. The numbers in the multiplication fact 2 times 4 equals 8 can be arranged to form 2 division facts. Remember that early on in the younger grades, we did math fact families where you did 2 addition and 2 subtraction. So an example of that would be like 2 plus 4 equals 6, 4 plus 2 equals 6, 6 minus 2 equals 4, and 6 minus 4 equals 2. That would make a fact family. They all work. Those are all true statements. But when we look at multiplication, we can make multiplication and division fact families, but it will be a little bit different because there's specific places the numbers can go. And if you look in this box here, you always have the product. So the answer of two numbers gives us the answer. So the product divided by one factor equals the other factor. Or the product divided by the other factor gives us the first factor. So we can make 2 times 4 equals 8, or 4 times 2 gives us 8. That's true. But for the 2 division facts, the product has to be in the numerator. So it has to be 8 divided by 4, which gives us 2, and 8 divided by 2 gives us 4. We cannot do 4 divided by 8 to give us 2, because that would not be true. 4 divided by 2 equals half, which is not one of our factors. So if we attempt to form two division facts for the multiplication fact 2 times 0 equals 0, one of the arrangements is not a fact. Which arrangement is not a fact? So if we do 0 divided by 2 gives us 0. If we do 2 divided by 0, that should give us 0. That does not work. And if you did 0 divided by 0, 0 divided by 0 should equal 2 based on based on our fact family, and that is not true. So the only one that works would be 0 divided by 2, which is 0. The other two is not a fact. Next, if we were asked to graph the following equations, what number could we not use in place of x when generating a table of ordered pairs? So to solve these, we just want to know what the denominator, just focusing on the denominator here. The denominator cannot equal 0. So if I make this x plus 2 cannot equal 0, I can solve for x by subtracting 2 on both sides, and I would have x cannot equal a negative 2. And when x is a negative 2, that makes that a 0 in the denominator, and we can't take 12 divided by 0. So here, x cannot equal negative 2. Here, in this one, if I divide by x, it cannot equal 0. And so we end up with x cannot equal 0. The second equation here, make that not equal to 0. To solve for x by adding 3. So here, x cannot equal 3. And if x was 3, it would make the denominator 0, which we cannot divide by 0. Next one, 6 divided by 2w. This cannot equal 0. To get w by itself, the opposite of multiplication is division. So whatever I do on one side, I do on the other. And I'm left with w cannot equal 0 divided by 2 is 0. So anytime you're just multiplying a number by a variable in the denominator, the variable cannot be 0. Next one, y plus 3 divided by 2y minus 8. This cannot equal 0. So to get 2y by itself, I add 8 to both sides, and I get 2y cannot equal 8. To get y by itself, I divide by 2. And I'm left with y cannot equal 4. So if y is 4, that would be undefined, which means you cannot solve it because the denominator equals 0. Next one, 16 divided by x squared minus 4. This cannot equal 0. So I have x squared. And to get x squared by itself, I add 4 to both sides. So I have x squared cannot equal 4. To undo a square, find the square roots. That means x cannot equal a positive or a negative 2. And the last one here, 3ab divided by c. c just cannot equal 0. And our appendix lesson for today, the quadratic formula. The quadratic formula is ax squared plus bx plus c equals 0. And you can see how they went from standard form to the actual formula, which is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. This is your a, this is your b, this is your c, remember, just the numbers. So we're just going to use those, substitute those numbers into the formula to solve for x. So here, if you don't see a number in front of the variable, that means it's a 1. Here you have a -5. Always keep the sign with the number. And C is +6. And then you substitute those in there to solve. So let's try one on the right-hand side here. So this is our A, this is our B, here's our C. So I have x equaling the opposite of B, which is -12, plus or minus the square root. Our B is -12 squared minus 4. Our A is 2. Our C is 10. Divide that by 2 times our A, which is 2. So simplify, I have 12 plus or minus -12 squared is 144 minus 4 times 2 is 8 times 10 is 80. So I have 144 minus 80, which is 64. So the square root of 64, divide that by 4, and I get 12 plus or minus, the square root of 64 is 8, divide that by 4. And the reason why this is plus or minus, because when you find the square roots, when you find the square root of any number, you have a positive root and a negative root. So now I'm going to have two answers. So 12 plus 8 is 20. 20 divided by 4 is 5. And then 20 or 12 minus 8 divided by 4. So 12 minus 8 is 4. 4 divided by 4 would be 1. So our solutions would be 5 and 1. And our last one here, your A, your B, your C. Remember this is a -1. So x equals a -1 plus or minus the square roots of -1 squared minus 4. A is 6, C is -1. Divide this by 2 times 6. Simplify, -1 is just 1 plus or minus the square roots. 1 squared is 1. 4 times 6 is 24 times -1 is -24. So 1 minus a -24 is 25. So this is the square root of 25 divided by 12. Simplify 1 plus or minus 5 divided by 12. We end up with 1 plus 5 is 6. 6 divided by 12 is half. 1 minus 5 is -4. Divided by 12 is a -1/3. So as our lesson today, division by 0, and the appendix lesson using the quadratic formula.